Günaydınlar herkese. Bekledik bir 4-5 dakika. Başlayabiliriz şimdi. Ben Murat Başbuğ. GTech'te Büyük Veri ve Analitik Direktörü olarak görev yapıyorum. Bugün konuğumuz Martin Payter. Gluent firmasında kendisi çalışıyor. Beraber size mevcut verilerinizi nasıl büyük veri ya da cloud'a atabilirsiniz, aynı zamanda oradan sorgulayabilirsiniz. Bunu anlatıyor olacağız. Ben kısa bir giriş yapacağım. Sonra kendisine söz vereceğim. GTech'ten biraz bahsedecek olursak 21 yıllık bir şirketiz. Veri üzerine odaklanmış bir şirket ve müşterilerine veri anlamında değer katmaya, veriyi merkeze oturtmaya çalışan bir şirketiz. Ondan fazla iş ortağımız var. Gluent de bunlardan bir tanesi. 200'den fazla müşterimiz bulunmakta. Her sektörden müşterimiz bulunuyor. Ondan fazla sektör üzerinde de etkinliğimiz bulunmakta. 170'in üzerinde de veri mühendisi, veri bilimi gibi danışmanlığımız bulunmaktadır. Demin de bahsetmiştim, birçok iş ortağımızda yön veriyoruz kendimize. Gluent de bunlardan bir tanesi. Gluent'le yola başlama hikayemizi anlatmak isterim. Büyük bir müşterimizde, banka müşterimizde büyük veri ortamındaki verilerini sorgulama ihtiyaçları bulunmaktaydı. Biz de tabii destek için bu konuda araştırmanızı yaparken Gluent firmasıyla karşılaştık, inceledik. Kendi laboratuvar ortamımızda denedikten sonra oldukça başarılı bulduk ürünü ve iş ortaklığına başladık kendileriyle. GTech olarak aslında iki büyük kırılımda destek veriyoruz. Bir tanesi veri ve analitik çözümler, bir diğeri de finans çözümleri. Veri ve analitik çözümler altında veri amberi ve iş zekası, büyük veri teknolojileri ve analitik, bütçe planlama, finansal konsolidasyon, veri tabanı ve sistem yönetimi desteği bulunuyor. Finans çözümleri altında ise bankacılık çözümleri ve risk analitik çözümleri yer almakta. Bugün tabii biraz konumuz büyük veri ve analitik üzerine aslında. Öncelikle biz bir büyük veri altında neler yapıyoruz ondan bahsedeyim. Akan veri işleme sürecimiz var. Biliyorsunuz büyük veri deyince meşhur 5V aklına geliyor. Hızlı artan büyük volümlerdeki verilerden bahsediyoruz. Bunda olmazsa olmazı tabii ki akan veri. Bu anlamda akan verileri işleme sürecimiz var. Bu anlamda teknolojiler de kullanıyoruz. Onun dışında tabii ki büyük veri ortamlarının bulunduğu Hadoop sistemleri üzerinde danışmanlığımız bulunmakta. Aynı zamanda da cloud tarafında da hizmetlerimiz bulunuyor. NoSQL anlamında da yine desteğimiz bulunuyor. Bu anlamda da Cassandra ve MongoDB kurulumu danışmanlığını veriyoruz. Onun dışında veri bilimi hizmetlerimiz söz konusu. Son olarak da uzman olduğumuz konularda eğitimler veriyoruz. Şimdi baktığımız vakit büyük veri ve analitik dünyasını aslında demin de bahsettiğim gibi veriler oldukça artıyor ve görüldü ki artık gerçek zamanlı verileri ne kadar hızlı anlamlandırabilirseniz ondan değeri daha fazla üretiyorsunuz. Bu anlamda da gerçek zamanlı verileri aslında baktığımız vakit işte bunlar arasında mobil daki veriler, clickstream verileri, sosyal medya verileri, sistem logları, CRM verisi gibi aslında birçok çeşitli veri var. Ve bunları anlık olarak yakalamak aslında Change Data Capture teknolojileri de mümkün. Farklı teknolojilerle de yakalayabiliyorsunuz. Bunları yakaladıktan sonra aslında işleme sürecinden geçiriyoruz. Aynı zamanda bu esnada siz alertler de üretebiliyorsunuz. Anlık alertler. Yani bu pazarlama uyarıları da olabilir. İşte görüyorsunuz, sıkça karşılaşıyorsunuz. Bir mağazanın yanına gittiğiniz an size SMS geliyor. Ya da güvenlik amacıyla da SMS'ler gelebiliyor. İşte siz yurt dışındayken size bazen belki SMS de gelmiştir bankanızdan. Bu tarz uyarılar da geliyor. Onun dışında gerçek zamanlı dashboardlardan da bahsediyoruz biz artık. Müşterilerimizin anlık olarak neler yaptığını görebilmek istiyoruz aslında. Daha sonrasında aslında bu verileri baktığımız vakit Big Data ortamlarına bazı müşterilerimiz cloud'a çıkamadıkları için içeride on-prem sistemler kuruyorlar. Bu Hadoop'ta olabiliyor ya da artık private cloud teknolojileri de var. Baktığımız vakit bu büyük verilerini bu ortamda saklama eğilimine giriyorlar. Cloud'a geçebilenler ya da yeni yatırım yapacak olan müşteriler cloud'u genelde tercih ediyor. Cloud'da da birçok seçenek var. İşte Amazon olsun, Google olsun, Microsoft, Azure olsun. Bu tarz seçeneklerimiz bulunmakta. Onun dışında tabii ki NoSQL dünyasına da girişler biz gözlemliyoruz bu ortamlarda. Verilerini bu ortama atmaya başlıyorlar müşterilerimiz. Tabii ki daha önceden yapılan yatırımlar ya da mevcutta da devam eden çalışmalar dolayısıyla her müşterilerimizin aslında mevcutta bir data warehouse ortamı bulunmakta. Bu sistemlerde devam edecektir aslında. Ama şöyle bir yaklaşımdan bahsedebiliriz. Bazı dataları artık offload etme yöntemine tercih edebiliyor müşterilerimiz. Offload edecek verileri de adaylar aslında soğuk dediğimiz veri tipleri oluyor. Bu soğuk veri tipleri işte son bir yıldır sorgulanmayan, hiç bakılmayan veriler de olabiliyor. Sadece saklama amaçlı aslında tutulan. Bunları bu ortamlara attığınız vakit mevcut ortamınızda daha katma değerli veriler tutabiliyor oluyor noktasına geliyorsunuz. Bu anlamda bir offload yaklaşımları bulunuyor. Aynı zamanda tabii ki bu diğer Big Data ya da cloud ortamlarının processing avantajı da olabiliyor. Ölçeklenebilir sistemler olduğu için daha hızlı sonuçlar da alabiliyorsunuz. Bu sebeple de offloadlar tercih edilebiliyor. Baktığımız vakit iki ortamda artık verilerimiz olmaya başlıyor. Bir geleneksel data warehouse ortamı, bir de cloud ya da big data ortamları. Şimdi bak alt tarafta da göreceğiniz üzere aslında bizim uygulamalarımız bulunmakta. Bu uygulamalarda data science amaçlı da olabilir. Ya da iş kullanıcılarının verileri sorgulamak amacıyla da kullanacağı ya da BI amaçlı da uygulamalar olabilir. Burada şöyle bir sorunsal çıkıyor. Verilerimin bir kısmı Big Data Cloud ortamında, bir kısmı da Data Warehouse ortamında ama bu verileri benim konuşturmam gerekiyor. İşte bu noktada aslında veri sanallaştırma dediğimiz konsept çıkıyor. Bu katman sayesinde aslında iki ortamdaki verilerinizi direkt sorgulayabilir noktaya geliyorsunuz. Birbirleriyle konuşturabilir hale de gelebiliyorsunuz. Aynı zamanda bu offload sürecini de yönettiği takdirde tam bir çözüm elde etmiş oluyorsunuz. Bu noktada işte kısaca bir Gluent'ten ben bir giriş yapayım. Sonrasında da sözü Martin'e bırakacağım. Gluent demin de bahsettiğim gibi aslında veri sanallaştırma şirketi. Amerika'da kurulmuş bir şirket. Oracle'ın gurularının kurduğu bir şirket. Çıkış noktası da aslında bu tarz mevcut ortamlardan başka bir ortama geçerken aslında müşterilere hiç kod yazdırmadan geçmek amacıyla çıkmış. Daha sonrasında farklı özelliklerini içine katarak aslında oldukça kuvvetli bir çözüme dönmüş bir çözüm. İki büyük özelliği var aslında. Birincisi verilerin offload edilmesi. Mevcut ortamlarınızdan, Oracle MS SQL gibi ortamlardan verileri desteklediği ortamlara atabiliyor. Bu desteğinin de sayısı oldukça artıyor. Şu an Snowflake, Cloudera, BigQuery, Azure Synapse gibi ortamlardan bahsedebiliriz. Bunu da otomatik yapıyor offload sürecini ve bu şey içinde güzel bir çözümü var. Yani hangi veriler offload'a aday, bunun için ücretsiz bir çözümü de var. Hemen analiz ediyorsunuz ve verinizin yüzde kaçı adaydır. Onu görebiliyorsunuz. Bir diğer özelliği transparan sorgulama. Bu verilerinizi diğer ortamlara, cloud'a ya da bir büyük veri ortamınıza attınız. Nasıl sorgulayacaksınız mevcut yerinizden? Bu özelliği sayesinde de aslında sizin sorgulamanızı sağlıyor. Hiç diğer yeni teknolojilerle uğraşmanıza gerek kalmıyor. Mevcut teknolojiniz üzerinden sorgulatıyor. Dolayısıyla kodlarda bir değişiklik yapmanıza gerek kalmıyor. Bu çok önemli bir konu. Çünkü kodlarda değişiklik yapılırsa biliyorsunuz yazılım eforu ve sonrasında test eforu gibi ek özellikler çıkacak. Bir de her yere yazmanız gerekiyor. Kaç yere yaptıysanız. Bunlardan sizi kurtarıyor. Artı transparan sorgulama tabii direkt sorguyu oraya atmak şeklinde değil, optimize bir şekilde atması da önemli. Yani hangi ortamla konuşuyorsa Snowflake'de ya da Cloudera'yla oradaki teknoloji uygun bir şekilde atması gerekiyor. Zaten know-how'ın da büyük bir kısmı orada diyebiliriz. O tarafta bir know-how geliştirmişler. O sayede aslında optimize şekilde sorguları oraya gönderiyor ve cevabı da direkt cevabı alıp size gönderiyor, geri getiriyor. Dolayısıyla mevcut ortamınıza da aslında bir yük, ekstra bir yük getirmemiş oluyor. Tam tersine yükü cloud ya da big data ortamınıza atmış oluyor. Çözümümüz böyle. Ben şimdi sözü Martin'e bırakmak istiyorum. Martin, I'm done. You can continue.
Thank you, sir. If you'll let me share. Thank you. How's that? We able to see the Gluent slide?
Yes.
Thank you, Murat. And thank you, GTech, for hosting this morning. Again, my name is Martin Painter. I'm Gluent COO. I'm here to talk to you about how Gluent Data Platform can help you do a variety of things. We're going to tell it in context to a story of cloud migration for Oracle databases and soon to come Teradata environments. We have two primary components to the architecture, data integration and data virtualization. So we'll describe how these two technologies combined together within Gluent Data Platform will enable you to, at a minimum, save money, increase performance, potentially depending on the platform that you're coming in, and ultimately provide cloud migration, advanced data analytic options that may not have been available to you without such a piece of technology in place. And just to summarize what we do at a high level, Gluent Data Platform, the software we provide, moves your data and processing from on-premise to cloud-native data platforms without the need for you to write any ETL jobs on the data integration side or rewrite any of the application logic that currently goes against your Oracle database and soon to be Teradata, as we'll have a release for Teradata by the end of this month. So in general, no code changes. We'll help you virtualize your data model into, we'll have examples throughout this demonstration of Snowflake and Cloudera. But as Murat had mentioned, we support Google BigQuery and Azure Synapse as well. Where the data model is virtualized, the data is both initially and incrementally offloaded to your cloud native data platform of choice. And then that allows us to push processing, especially analytic processing, from Oracle to one of these cloud native data platforms dynamically without any changes on your side. And that allows us to save money in a few ways. One is obviously storage, because of the data virtualization, what we move to that cloud native data platform can be dropped from Oracle. We'll talk about scenarios which we keep data in Oracle, and once we are able to move that data to that cloud native data platform, we can push the processing, which could reduce CPUs, license usage, hardware infrastructure, etc. So first, let's start with a couple of problem statements that we have with our customers. Our focus is on large enterprise workloads. Smaller Oracle workloads are not an issue moving to cloud today. 2 terabytes or less, 8 CPUs or less. This is small, it's lift and shift, we can move it pretty quickly. But a vast majority of our enterprise customers have experienced some type of failure or repatriation of workloads from cloud to on-premise. So 90% of CIOs have had a failed or disrupted data migration project. 72% of CIOs have had to repatriate a workload from cloud to on-prem, meaning they landed, they were running in the cloud, and for either performance or cost reasons, it was better to move it back to on-premise because they were not realizing the value that they anticipated. And the two scenarios that we'll outline in just a moment are you can lift and shift your workloads, meaning I'm just taking what I have today and moving it on to infrastructure on the cloud, but I'm not taking advantage of any cloud native architectures or technology, or I can refactor my application. The problem with refactoring obviously is timelines. Obviously at this point, you're rewriting code in order to take advantage of cloud native architectures. And that on average is taking our customers between 18 and 24 months before they're able to cut over and realize any value. Our typical customer, again, enterprise, we've got customers with, databases as small as gigabytes, but most of our customers are in the 10 plus terabyte ranges for the Oracle databases, where we believe we can add a tremendous amount of value, higher cost savings, more options for your enterprise. So let's go a little bit into what our customers have today from a choice. If I'm on premise and I want to realize cloud migration, I have two options traditionally. Lift and shift, as we discussed currently. I'm moving from on-premise to, I'll just use AWS as an example. I'm going to move it to an EC2 shape or an Oracle RDS shape, depending on what I need. Performance is typically not what we anticipated moving from on-premise to the cloud, typically due to storage throughput. In our experience, especially with Oracle workloads, storage tends to be the problem from a performance perspective on cloud migrations. Cost typically ends up being much higher than we anticipated because we're not able to dynamically scale. We can't, ultimately end up with a bespoke instance. We have to have it on all the time. We don't get that scalability option that the cloud provides us because we're just doing a lift and shift IaaS infrastructure. And then for those of you who are familiar with how Oracle licenses outside of their own cloud on OCI, which we'll talk about as well in this presentation, AWS, Azure, Google, you have to have double the licenses traditionally that you would have on premise. So again, even if you could move it to a workload where the infrastructure was cost effective and performance was cost effective, you may have a problem with your license compliance that makes it prohibitively expensive. Now, your other option, should any of those issues, be preventing you from doing a lift and shift, is to refactor. And this means you're doing a full analysis of your code base. You're determining, what do I rewrite in what language using what technology on the cloud? Traditional data warehouse, I'm moving from Informatica to a cloud native data integration ELT tool. I'm moving from Oracle database to perhaps a Postgres engine or to one of the cloud native data platforms that we talked about today. Google BigQuery is an example. Your timeline is long. Code is not fully compatible, so I have to evaluate the functionality, syntax. Even if I use a code conversion tool, maybe 80% of it is converted. It's typically the easy stuff. And now I have to go do the hard stuff. 20% fallout is 80% of the effort. And a lot of our customers' projects fail as a consequence of obviously there could be personnel changes, or the cost is prohibitive for having to maintain two environments for 18 months while doing all the extensive evaluation and refactoring and testing. And then you have to have new skill sets. Obviously, you're turning a lot of, probably 20 plus year PL SQL developers from an Oracle perspective into Snowflake SQL, Python, JavaScript people, and you just don't have that depth of abilities. And so what you're able to do on the new data platform may not be as robust as what you know on the legacy platform. And with Gluent Data Platform, what we attempt to do with the software is basically combine factors of both of those approaches to make it so that you can cost effectively migrate your Oracle database to IaaS infrastructure or PaaS offering, depending on the flavor of it for the cloud. But we reduce the Oracle footprint, both from a storage and processing perspective, that EC2 instance, if you will, is so much smaller, what you need from both storage and CPU perspective, that you're in compliance with your license without having to buy any more licenses, that your performance is the same or better as it was in the cloud, and that your cost is lower to run the infrastructure for the Oracle database. And we do this, there's two primary components that you see on the right-hand side of the Gluent node cluster, and that's the automated data movement from the Oracle database or Teradata into one of the cloud native backends, such as Google BigQuery, Azure, Cloudera, Oracle Autonomous and Redshift are on our roadmap, so those will be supported soon as well for backends. And that what that means is we look at your Oracle schemas, we create the equivalent schema on the, let's just say Cloudera side. We handle all data type mapping, so you don't have to figure out if I have a timestamp here, do I need a time or timestamp here on your backend side. The initial data movement, if a customer is running 10 terabytes and we say 9 terabytes can be migrated to Cloudera and dropped from Oracle, we'll handle that initial movement plus any incremental movement. And we have a variety of options to capture changes for customers to make sure it's in sync. Now, all of that falls into the data integration category, of which you have a lot of options. The thing that really makes us different is the ability to now recognize that data, those tables, partitions, and data are in Cloudera, and for Oracle to treat it as if it's part of the application. It knows no different. And that's where our Gluent query engine comes in and that translation comes into place. That piece is what allows us to drop data in Oracle, because Oracle will now reach through and determine that data is in Cloudera. It'll push the processing to Cloudera. So like Exadata storage, we'll push down aggregations, predicates for filters, right? Join clauses. We'll dynamically push that down so that instead of bringing back all the data out of a table in Cloudera or a partition, we're going to bring back just the data that's required to satisfy the query that was issued against the Oracle database. And this means, and there'll be a demo a little bit later that goes into this in a little bit more detail. It means that I'm taking advantage of the distributed processing of that cloud native backend to bring back just the row set I need to satisfy the query that the user or the application issued. And even though we do introduce a small bit of latency with integrating between an on-premise Oracle database and a cloud native data platform, right? Just the nature of physics and networking, the processing is so much faster on the Cloudera side, and we're only bringing back the data that we need, that quite often we're seeing pretty dramatic performance gains. At a minimum, it's no different than what you have currently. And at a maximum, it can be significantly faster if we're able to pass down something that even an Exadata can't, like a join across data sets, where Exadata can only do that across an individual storage server. We can do it across the entire data set. So the way we like to explain it to a customer is day one, we install and configure the Gluent data platform. And that's its own cluster that can scale both vertically and horizontally, either on-premise or on the cloud, depending on your infrastructure. We can migrate data on day two. It's a background process for us, a batch process. So it could take a day, it could take a month. It kind of just depends on how much data the customer has to move. Obviously, a petabyte takes a lot, it takes more time than a terabyte, but it's a background process. It's seamless. There's no outage requirement for you. Once that data, the initial one especially, is synced and moved over, then we can drop data in Oracle, we can incrementally sync it. And that's once that data is over into Cloudera in this case, that's when we can dynamically move processing to the cloud native backend. And then the immediate benefits are you're not spending any time evaluating schema, right, conversion, data type mapping. That's handled automatically with the auto data movement. Where handling the initial and incremental data loads fully managed. So even though if you're just doing, lift and shift straight ELT with no transformation, just, pull from Oracle, push to Cloudera, we do that all dynamically, as opposed to, creating a mapping in Informatica, for example, one by one. And so we're significantly faster, and it's automatically maintained through a GUI or an API layer, command line layer. You don't have to do any of that. And then the processing is pushed dynamically as well. So you don't have to determine, should I move this table over and push processing against this table or partition? We leverage the power of Oracle's own query optimizer to determine which query should be pushed to where. So what that allows us to do is accelerate your migrations. And again, we'll go into a graphic in just a moment that shows the various steps where you could stop any time throughout the process and realize benefits. but we'll accelerate your migration. So instead of you having to rewrite a bunch of code or experience poor performance, with a lift and shift, we can move data and processing in days and weeks, where you get that dual advantage of, cheaper infrastructure from an Oracle database perspective, but you get the scalability of that cloud native backend, such as Cloudera. We decrease risk. A vast majority of these projects fail as a consequence of being unable to take a 20-plus-year-old Oracle SQL engine and try to convert it to the same features and functionality in a 5-10-year-old, Cloudera, kind of Impala SQL engine. There's obviously a lot of differences there. So we take that risk out. The best of what needs to happen on Oracle happens on Oracle. The best of what we can do on Cloudera happens on Cloudera. We've already mentioned the increase in performance. Again, that kind of depends obviously on the workload. The more analytical and set-based in nature, the more performance gain we're going to be able to get out of those cloud-native data platforms. We're obviously looking to optimize costs between these two platforms, and we are both full hybrid cloud and multi-cloud compatible. Hybrid cloud meaning I can keep my Oracle database on premise and integrate with a cloud-native data platform on one or more clouds. Or perhaps I move my Oracle database to OCI and I integrate to one of the other cloud players, AWS, Azure, Google, right, for my cloud native data platform. We'll show a couple of scenarios where we're able to share data amongst those environments as well. But ultimately, what we are attempting to enable is a successful migration for you to realize a cloud migration for reduced costs, increased performance, without dramatically upturning your own internal shop. So let's kind of talk about what the cloud migration process looks like and the various steps. I'll speak to a couple steps where customers stop and what they expect and what they realize. So we start with our traditional Oracle Red on-premise database, and we want to move some of this data to a cloud-native data platform. So we install the Gluent layer. We'll talk a little bit later about what that looks like, right? What we need to install on an Oracle database and the infrastructure. Once Oracle Gluent's installed and we've analyzed the database, we can begin offloading data to a cloud-native data platform. In this case, we're using Snowflake, but it could be Cloudera, BigQuery, etc. We offload the data both initially and incrementally. And now we've enabled transparent queries so that we're able to query that data hybrid style. Again, all your application querying is coming in via the Oracle database. The optimizer opens up and determines that these tables are now managed in Snowflake. Gluent gets called to write the query against Snowflake, again, pushing down predicates, aggregations, joins, etc. The query is issued in Snowflake. Snowflake returns the results. We ship that back to Oracle to be stitched back together. What that allows us to do is to delete that data out of Oracle that we no longer need, and dramatically shrink this Oracle footprint. Now, customers stop here all the time. I've saved a bunch of money. Maybe I was on Exadata and I'm growing petabytes a year and I'm going to have to buy 10 more Exadatas, and I just don't need it. I don't need I love it. It's a great platform, but I don't need the storage for the cold data. I'm just paying for very expensive storage to archive this data. Well, now it's in Snowflake or it's in the cloud at, typically 10 to 20 times cheaper storage. And I can reach through and grab it anytime I want without having to change my application or create any ETL processes. I'm happy. I've got the best of it. I've got the best in the world on an Oracle Exadata. I've got the integration with the cloud native data platform. I'm done. A good chunk of customers stop here if they don't have full cloud aspirations. However, now that we've shrank that full Oracle footprint to such an extent, the traditional limitations of I need double my licenses, I need very expensive storage, bespoke storage in the cloud to mimic my Exadata storage, all those are gone because now a lot of that processing and the storage is now in Snowflake. So I have that option of lifting and shifting that Oracle database to the cloud should I choose. Customers want to exit a data center, or they simply are perhaps going to archive this application and they want it on as cheap of infrastructure as possible as they go build the next great application that's going to run their business. But in this scenario, all of your loading, all of your ETL, everything that you do traditionally, because again, we're not looking to have you rewrite any code, continues to go against Oracle. And Oracle then, between Oracle, Gluent Data Platform, and Snowflake, all this processing occurs. Your reporting, so you have both your loading component to the right and you've got your reporting component to the left. All of your reporting continues to go against Oracle as well. This is where a customer, should they choose ultimately that they wish to get off of Oracle, can do a incremental migration. And so in this case, what we're depicting is now I can land my data in Snowflake. I can rewrite my ETL to go against Snowflake natively. Those tables are presented to Oracle. So Oracle still sees them, right? Any SQL that you write against Oracle sees those tables in Snowflake as if they live in Oracle. My reporting can continue to go against Oracle, even though all of my loading and ETL is in Snowflake. And I can live like this, for example, should I choose. Ultimately, we can now rewrite our reporting against Snowflake, and we no longer need the Oracle database in this instance. Again, should that be an aspiration for the customer. And therefore, Oracle's gone. You've now completely migrated incrementally to your cloud native data platform, and everything runs here. One thing I'll point out about Gluent is you'll notice Gluent's gone along with the Oracle database. Again, one of our components is moving data from Oracle to Snowflake. The other is that we present data that's created, whether we moved it or whether it's created natively in the cloud native data platform, like Snowflake, we can present it to any Oracle database. So for example, perhaps you wanted to get off of Oracle from your analytic databases, but you love Oracle for your OLTP databases, right? Anything we add to Snowflake, we can present to Oracle. We can use Oracle SQL, PL SQL syntax to query that data in Snowflake, and you don't have to move the data. I don't have to add all this value in Snowflake and then move the data to my OLTP application for that OLTP application to use that data. I can write queries against it. All the processing happens on Snowflake. You get all the same benefits. So Gluent may live in your environment even after you've decided to move off of an analytic database on Oracle for that data sharing component. Okay, so we enable the incremental rewrites. We enable downstream reporting to be repointed. And ultimately, again, should you choose, decommission your Oracle database. Let's talk a little bit about the architecture. It's a little cartoonish, but essentially you've got your application that, again, is issuing logic to the database. The database, again, it's the query, SQL is issued from a user of the application to the Oracle database. Optimizer wakes up, determines an execution plan. Gluent gets called because we are an external table preprocessor. So an external table preprocessor gets called because it's an external table in Snowflake now. We write that query against Snowflake, return the results. So that's where that Gluent layer gets installed. We do require the ability to install on the compute nodes of an Oracle database, fully supported on Exadata, Cloud at Customer Exadata, really anything that allows you as a customer to have access to the OS on a compute node, we can install Gluent Data Platform against. So we insert ourselves right here. Advisor, we'll talk about it at the very end, is a pre-sales tool that we use in order to identify what are the tables and the processes that we can move to that cloud native backend before you as a customer make any commitment, and therefore how much value can we add to your environment. We've discussed at length the automated data movement, again, automatic creation of the schema, data type mapping, both initial and incremental data movement, and then obviously what we believe differentiates us more than anything else, the ability to push that processing to the cloud data platform without you rewriting any code. So this is kind of the architecture. And again, we support a number of SQL engines because ultimately, that's what you're leveraging as opposed to just dumb storage. You're actually leveraging Impala, slots on Google BigQuery, et cetera, in order to do processing against that data set for performance. So I'm going to show you a demo, take about 5 minutes to give you a more detailed analysis of how the product works. So let's start.
Data virtualization capabilities. Gluent Data Platform supports a number of use cases, including database offloading to Cloudera Data Platform. For example, with Gluent Data Platform's offload component, you can shrink your large Oracle databases by moving most of the data to a Cloudera backend. Here is an example of a Gluent Advisor report for a 76 terabyte Oracle database. The report shows us that 71 terabytes are consumed by database tables and indexes. Of this 71 terabytes, Gluent Advisor has identified that over 90% of this data can be offloaded. And when this data is offloaded,
so I'm going to pause for just a second. It's important to note that we can move all 71.7 terabytes in this case to your cloud native backend of choice. When we show you that we can offload 91%, this means that this data is cold enough. It's not OLTP data. It's not frequently updated, that we can drop this 65 terabytes from Oracle and you will not experience any performance degradation. So just a key note here, all data can be moved, so you can rewrite reporting and do analytics over there, but we can drop 91% from Oracle in order to benefit you financially. Less storage, obviously processing going to Cloudera in this case.
Cloudera, existing Oracle database applications won't even notice, thanks to Gluent Data Platform's transparent query capabilities. We can drill down further into this offloadability and examine the hotspots within the data. For example, we can examine what offloading 75% of the data would look like versus the recommended 90%, or even assess what would happen if we adjusted to a higher ratio of 95% offloadability. With this scenario, we can see too many red areas. These table partitions are too hot, so we would not recommend dropping 95% of data from this particular database. But 90% appears to be safe and achievable. Let's move on to offloading. I've already offloaded data many times in this environment, so the majority of the work has already been done. I'm just going to pick one schema of interest. Some changes have been detected for some tables since the last offload. Gluent Data Platform will offload the new data to Cloudera seamlessly and keep it synchronized between the Oracle database and the Cloudera cluster. Now that the latest data has been offloaded to Cloudera, we can move on to the next phase of the demo. Offloading data to Cloudera is only half of the Gluent story. We go beyond just moving your data, and instead we truly virtualize it. With Gluent Data Platform's table virtualization, you can still access all of your data after offloading. And critically, this means that you can still run your existing applications. They will be unaware that the data was moved. We call this transparent query. Let's see transparent query in action. Here is a typical Oracle data warehouse query. It is a 5-table join with some aggregation syntax such as grouping IDs and rollups. It even has a proprietary Oracle PL SQL function. This SQL statement will not run on non-Oracle databases directly. It is proprietary SQL meant to run only on Oracle databases. Developers have used proprietary code like this for years, often to get the best out of the data platforms that they deploy their applications on. Re-engineering code to suit new platforms is difficult, and the time and costs to do this are prohibitive. Gluent's transparent query engine enables you to take advantage of Cloudera's platforms for your data, but without the time and money associated with application rewrites. I'll run this query twice. First, I'll run it in the Oracle environment. Second, I'll run it with Gluent's data virtualization enabled to access the same data, but from Cloudera. The monitors to the left will help us to visualize the query's processing requirements in both environments. The top server is an Oracle database server, expensive and not very scalable. The bottom servers belong to a Cloudera data warehouse cluster in the cloud, which has the ability to scale out compute and storage at a reduced cost. As I mentioned, the first query will run entirely in Oracle without Gluent's data virtualization. This means that all processing will be done in Oracle. The query executes in parallel and uses 16 CPU cores. Again, all of the disk I/O and CPU processing is happening in Oracle. The scanning, filtering, decompression, aggregation, joins, and so on are all using the Oracle infrastructure and expensive CPU cycles. For the second run of this query, I'll enable Gluent Data Platform's data virtualization. The data for this demo has already been offloaded to Cloudera, as we saw earlier. Instead of accessing the data from the Oracle database, we will transparently access the data from the Cloudera cluster to satisfy the query. We will push the heavy processing to the cloud infrastructure rather than use the expensive Oracle database server resources. I'll now rerun the query without any changes. I haven't logged out of the system, and I'm still in the same screen. Only Gluent's data virtualization has been enabled at this point, but my application is still connected to the same Oracle database. This time, the query required barely any CPU or disk I/O cycles on the Oracle database server. Instead, the bulk of the work was pushed to the Cloudera nodes by Gluent Data Platform's transparent query engine. Furthermore, the query completed in 2 seconds instead of 12 seconds. because we were able to take advantage of the full processing power of the Cloudera cluster.
So I'm going to stop here a second again, because I want to make sure we note the difference. So this is traditional Oracle database, so non-Exadata in this case. So you're bringing all the data back from storage and you're spinning CPU cycles, determining which obviously rows, columns you need to satisfy the query to return back to the application. Very stereotypical, kind of Oracle workload. You'll notice here, there is no CPU executed, practically none on this side, other than what needs to be handled for things like the PL SQL code that continues to execute on the Oracle side. And we've got a spike across the Hadoop cluster in order to execute the query and return the result set. So again, dramatically different footprint. And this is ultimately what allows us to say, if you're running in a 16-core Oracle box, on premise, we probably only need 8 cores in the cloud or less, depending on how analytical your workload is. Again, Advisor helps us identify that in advance of any activities with a customer. But you'll notice latency has been added. This execution is just on premise on Oracle. This execution is on Oracle on premise with a Hadoop cluster in the cloud. And what you'll note, if you remember, it was a 12-second return on the query against just Oracle, and it was a 2-second return on the combined environment of Oracle on premise plus Hadoop in the cloud. So again, even though there is latency introduced, roughly a second, let's say, right, compared to what you would have traditionally, our processing was so much faster because of the backend we use, in the case Hadoop, and the fact that we're only getting the data that we need, not all the data to spin CPU cycles. It's a dramatic reduction both in the amount of time it takes and the amount of resources on the Oracle side. So let me share again the PowerPoint. Okay. And what we'll do is we'll dip a little bit into the data virtualization piece, which is what makes us special. The thing is that although customers will use us as a use case to get completely off of Oracle, we don't do anything to enable that. Meaning we don't convert code, SQL or PL SQL, right? We don't convert it from one language to another. There's obviously a variety of tools out there that do that. What we do is that translation. And what Gluent allows for is transparent. Our transparent query engine, it specifically allows for fast and secure Oracle SQL queries against all of your data. Your team doesn't have to learn any new skills. So if they're SQL, PL SQL developers, they can continue leveraging SQL and PL SQL, and you don't have to change any code or move any data from your legacy environments to take advantage of these new cloud native data platforms. So we asked the question based on historic projects, what if there was a way to use a single SQL engine? In our minds, Oracle is by far the most mature and most robust to access all your data with no need for additional training, no requirement to move data, and then obviously potentially increasing performance depending on how you take advantage of the cloud native data platforms. And that's where the idea of Gluent Data Platform was born. So we want customers to have the ability to use those Oracle skills they've developed across their team over the years in order to query data against these new cloud native data platforms. We want your current Oracle SQL-based applications to be able to seamlessly integrate with these cloud native data platforms without extensive outages and rewrites, and pain, right, for the customers to take advantage of them. We want you to keep it secure. So there's a lot of detail on the security protocols that we leverage and use, but ultimately the security, you get the benefit of cloud from a security perspective. You continue leveraging the Oracle security practices that you have in place, in addition, obviously, to being able to take advantage of the cloud native features. You don't have to move any data to analyze it, and we can increase performance. All of that without you having to rewrite any code. And so we kind of depict this as, this is kind of hey, I'm an Oracle customer. I love my Oracle database. I want to continue leveraging all these other cloud native data platforms because we're a big enterprise. We have a lot of uses for all this technology altogether. And Gluent helps to combine all of that. So our traditional on-premise topology, for a lot of customers that want to keep Oracle in the mix, you've got your on-premise Oracle database. We have Oracle Cloud, where we can run the Gluent infrastructure node. A lot of customers will start this way: multi-cloud integration with a major cloud provider, such as AWS, Azure, or Google. So there's a lot of customers that have AWS, let's say, as their primary enterprise cloud, but they're using Oracle for their specific Oracle applications, and this works just fine. Like, we have customers with this type of scenario. Ultimately, though, customers are aspirationally exiting a data center and they're trying to get their Oracle workloads to Oracle Cloud. They're getting their non-Oracle workloads to one of the MAGs. And this is what our customers' environments look like at that point: taking advantage of Oracle Autonomous Database, Exadata Cloud Service, Oracle Cloud Database Infrastructure, all these powerful PaaS database offerings that exist in Oracle's environment, with superior throughput for performance, right? Effectively, competitive costs from a customer perspective. That Gluent cluster can run obviously in Oracle's cloud. It can also run in any of the other cloud integrations that you're doing. We obviously can integrate with Big Data Cloud Service just as well as any of the AWS, Azure, or Google cloud native data platforms that are depicted on the right. And so for a customer that's in a multi-cloud, hybrid and multi-cloud type topology, there's all number of combinations that we can enable here. But this is aspirationally where a lot of customers are looking to go. I have big enterprise workloads. I can't do the time and expense to rewrite them. It's most cost effective for me to put those into Oracle's cloud to take advantage of that Exadata infrastructure or compelling storage. But I have to integrate with these other platforms, other lines of businesses, et cetera. They've made these commitments to either a big cloud or to these cloud native data platforms. And we help glue all that together, if you will, for minimal data movement, minimal code rewrites across your landscape is ultimately what we hope to enable. So the benefits, ultimately, I'm hoping, that I was able to depict throughout the presentation: reduced infrastructure costs. We certainly can reduce storage. There's no question. Obviously, it's typically cheaper to run things in the cloud than it is on premise, but obviously customers vary in that regard. At a minimum, we're going to save you storage. At a maximum, we can get you off of perhaps Exadata. Maybe that's something that you no longer need because we are turning Cloudera into computational storage like Exadata storage servers. And so I don't need Exadata anymore per se. Even though I need that Oracle database, I don't necessarily need Exadata. And so now I have the ability to go to a cloud like AWS, where before I might have been only able to go to OCI. Right? These are options that we can enable for a customer. And the more of those options we're able to give you, obviously, the more effective the cost reduction can be. Query processing time. Again, if you're not on an Exadata today, there's no question that analytic queries are going to be significantly faster with Cloudera, Snowflake, et cetera. We just did a customer where a 6-hour query on Exadata was 6 minutes on an extra small Snowflake warehouse, for example. So there's tremendous amount of performance to be gained if we can get it without having to rewrite all this code and take all the time to do it. But as a general rule, what we'll tell customers is non-Exadata, we're going to be much faster. Exadata, it's about equivalent, where you can move off of an Exadata and keep the performance you're used to, just to give you an example. And then obviously we've already discussed storage. Cloud storage is anywhere from 10 to 20 times cheaper than traditional storage. And so even if you can't get anything other than moving that old archive data off of your expensive enterprise storage, traditionally the way we price Gluent Data Platform, either fixed for a customer or consumption-based, it's going to be cost-effective to get that data off of the Oracle environment and onto cloud, storage environments. So I'll just very quickly, because I know we're running out of time, so we have some time for questions. I'll give you 2 use cases that we have for a customer. This particular one is a relatively large 15 plus petabyte of data in an Oracle Exadata environment. They were struggling extensively on how do I continue to access this data, we'll call it intelligent archiving, without having to do very elaborate ETL processes, which is what it takes today. They have to offload the data, delete it from the Oracle database. If you need it, you have a 24-hour turnaround process. They have to restore the data, customers query against it, and then they delete the data again. It's very manual, very intensive. And so we moved a petabyte in the first year. We're in the process of moving 3 additional petabytes now. This one is Google BigQuery. So they're migrating off of an on-premise Exadata data warehouse environment, and they're moving to Google BigQuery. And we deleted the first petabyte. We're working on moving and deleting the next 3 petabytes. And this is going to avoid the purchase of another 10 Exadatas over the next 5 years. They love it. They don't want to get off of it. The application continues to run on their existing infrastructure, but they no longer have to buy it simply because the data is growing exponentially. Now they're able to take advantage of cloud infrastructure. And so performance has increased. We had a 66% total cost, operating cost reduction in the first year. And based on how we priced it, about 190% return on their investment. And that's what they spent on Gluent and on our on the Google infrastructure. And then this one, really quickly, this is HP. Public reference for us. There's a video that talks about their environment. This is a Cloudera backend, industrial printer division. And so it's an IoT use case. So these printers are streaming off massive amounts of log data. They want to analyze that, use advanced analytics, AI, ML to do preemptive analysis on failures, et cetera. And it was on an Exadata, and it was getting very expensive, and processing was extremely slow attempting to analyze this. And so moving it, about 80% of the data off and into Cloudera environment resulted in a dramatic reduction of cost. All of this is on premise on this particular sample, and a significant increase in performance. And so they continue to leverage this environment in production today. So Murat, next steps. So anybody who's interested, as I mentioned with Advisor, install nothing, SQL script, we'll analyze your Oracle environment and come back and tell us how much data you have, how much data we think we can move and drop. It enables us to give you an idea of what the environment would look like in the cloud, and whatever cost savings we think we could provide. And with that, Murat, I will stop for questions.
Thanks, Martin. That was really impressive examples, especially the last example, HP. Let's pause here for questions. I see that there are a few questions, Martin, related with the last advisor. I think this question is related with that. How do you analyze cold data?
Yes. So we are looking for 2 things when we identify the data that we'll say cold. Basically, it's data that's not low latency queries go against it, or it's updated frequently. In our advisor output, we're looking for AWR and Ash retention. We're leveraging AWR and Ash in the Oracle database to do the analysis. If it's 1 million block changes or less over a 30-day period, then in our experience, that's data that's cold enough, if you will, that we can move it to Cloudera, drop it from Oracle. And if you do processing against it, updates, right, et cetera, we don't experience a performance issue by moving it off. So we're looking for low latency queries to go against it, like single row lookups. Obviously, if that is there, then we're going to delete. We don't want to delete that data from Oracle. And if it's updated frequently, then we want to keep a copy of that data in Oracle as well. So those are kind of the 2 criteria we evaluate when we come and say 80%, 90% can be moved.
That's great. Another question is, when will MS SQL be supported? I see that Teradata has come into support besides Oracle. What about MS SQL? The question is about this.
We actually have a beta of Microsoft SQL Server today. So remember, there's 2 components. There's data integration, so the creation of the schema, moving the data, and then there's data, the query processing that we can push. Oracle is fully supported in production on both. We have a beta for SQL Server that will do both pieces of functionality, and it's really just been a matter of demand. As you can imagine, the bigger the environment, the more money you're going to save as a customer leveraging Gluent Data Platform. We tend to see a lot more large Oracle databases in customers' environment than SQL Server. Plus, there's a lot of options across all the clouds to host SQL Server. So we have a beta. We're just looking for the right customer that's got a big enough environment for us to, finish it up and have a production environment. Roadmap wise, I would tell you that from a front end, it's Oracle. Teradata should be fully supported by the end of the year. So we'll have the data integration piece done by the end of this month in production, and the full transparent query piece by the end of this calendar year. SQL Server would be the next one for us to tackle, sometime in 2023.
Okay. There's also a question. It's a bit technical, I think. So this is about the demo.
Mm-hmm.
How did the UDF in the demo get translated into Cloudera environment?
Yeah, that one, we have extensive documentation on the UDF. So if that question we can answer, like with an email or response, we'll be happy to provide you more detail on that, no question.
Okay. If there are other questions. We're almost on time. Yeah. So thank you, Martin, again, for participating on this panel. We can close it if there are no further questions.
Appreciate you guys having me. Thank you for the time.
Thank you. Teşekkürler herkese. Görüşmek üzere.